Okay, so quick refresher before I let you dive in this. And obviously these are in order, but your quiz might not necessarily be in order. In the beginning in 210, we talked about how to determine if data was exponential or log. Do we remember the difference? Okay. Which one?
The inputs, and then the outputs are increasing additively.
Good. So if the inputs are going additively and the outputs are multiplicatively, that's exponential. Okay. And then the reverse, which is what you said, which the reverse is log. No, you were right. You just said log. The reverse is log. If the inputs are increasing multiplicatively, then the outputs are increasing additively. So the wording there is as the inputs are blank, the outputs are blank. Okay, that's how you would justify it. Yep. Okay, so we talked about this before already, but determine if the data represents a log or exponential function because the input values are increasing multiplicatively as the output values are increasing additively. This would be log. So as input, and you need input, not x. It has to be input. Increases multiplicatively. Missed my V. Multiplicatively. Output increases additively. And again, I'll take proportionally for multiplicatively, but you have to have something, and you have to describe both. And then if I asked you to give me the inverse, which the review does, what would you do? If I asked you to give me the data of the inverse. Just switch your x and y values, okay? Multiplicatively, okay? You'll also see proportionally, because that means the same thing. Sure. Okay, then we get to the inverse. So this was, now we're finding the actual inverse. We did two things in this section, which was not just two things, but two things with inverses in this section. One was showing that something was the inverse. So you did f of g and g of f, and it should have canceled and given you what? Just x, good. And then if you're finding the inverse, we're going to take our x's and y's, we're going to switch them, we're going to solve for the new y. So you could have to be doing that with the log, right? So if it's exponential, we're bringing in the log. And if it's log, we're converting it to exponential. That's 2 and 3. 2 said find the inverse. So because this starts exponential, or there is an exponent in it, does not mean you log both sides. So a lot of people did that. When you log both sides, that's because your base is a number. So if it's an exponential expression and it said 3 to the x, now I can log base 3 both sides. But don't bring in a log on something that is not exponential, but the base itself is not a number. Does that make sense? You're doing the inverse of raising it to the third power, which would be taking the cube root. So a lot of people try to log. If it said f of x equals 5 to the x, now I can bring in the log. Does that make sense? Yes, we understand the difference between those two. So if the base is a number and the exponent has the variable, that's when I would log both sides of my equation. And I would log base 5 that. But if it starts the way that this one did, I would going to make this x. I would divide both sides by 5. X over 5 equals y to the third. And then I cube root it. So I get f negative 1 of x. And don't forget that because you will get docs points. It has to be f negative 1. And it's the cube root of x over 5. That cube root goes over both of them, so that whole thing has to be underneath the root. Then you get g of x. So this time I'm going to switch it and make it, again, this would be the x log y minus 2. In order to convert this to the inverse of log would be exponential. I convert it to exponential. But before I can do that, I have to get rid of the 5 on the front. So I'm going to divide both sides by 5, and I get x over 5 equals log. And what is the base on that log? 10. So 10 comes over and picks up the exponent. And then my last step is just to add the 2. So I would get g negative 1 of x. And I would get 10 to the x over 5 plus 2. So some of you made it like f negative 1. I don't know if I'd take off points for that. But if you don't do the negative 1, you're definitely going to lose points. Because this is not our original equation. We changed it. You have to show it by using the inverse notation. Yeah. Yep.
The log just disappears.
We're converting it to exponential. So we convert from one to the other. That 10 picks up the exponent and the log goes away. Yep. Then we got into 212, which was all your condensing and expanding. So remember, if we condense, if there's a number on the front, it becomes the exponent. If there's addition, it becomes multiplication. If it's subtraction, it becomes division. All right, then 4 said condense. Most of you did pretty good on this, but remember, if there's 2 minuses, that means eventually I have to condense this all down into 1, and there should be no adding and no subtracting. So the positive one is a multiplication. The negative one becomes division, goes to the bottom. So I would get log, first of all, these exponents would get bumped back, and then I would get log x to the 2/5 over y to the 3rd, z to the 5th. And some of you left it like that. I may take it because it is equivalent, but really you want to go to the next step. I want to change that so that it's the 5th root of x squared, and the squared could be underneath with the x or on the outside, over y to the 3rd, z to the 5th. So this could also be written as log 5th root of x squared, like that, over y to the 3rd, z to the 5th. But we typically don't leave fractional exponents. Like if that was a 1/2, you have to rewrite it as a square root. Does that make sense? It has to be rewritten. So these. So there's a condense and then there's 2 expanding on this, okay? And the reverse happens. If we are expanding and it's multiplication, it becomes addition. If it's division, it becomes subtraction. And the exponents get bumped to the front. Now we're expanding. So number 5 started with multiplication. So this becomes addition. And that 2 is going to get bumped to the front. So it'd be 2 ln z. I think everybody did that one right. 6, couple mistakes were made. 1, there are 2 things in the denominator. They both get a minus. 2, some of you lost the base. You can't lose the base. Like you cannot rewrite this as log. It has to say log base 5. So log base 5 of x, the 2 would come to the front, minus the 2 from the y, log base 5 of y, minus the 3 from the z, log base 5 of z. Again, don't lose your base. Yeah, after, who just went? Jordan. And then we did a lot of stuff with the graph. So this one actually asks you to graph it. The next one is just going to have you estimate it. But this is an estimation of your graph. So you can take your log if you know what your log looks like. I'm not too worried about the base, so it doesn't have to be perfect. But you're looking for your transformations. So the front, if it's positive or negative, positive log goes up and to the right like an r, like a lowercase r. Okay. If it's negative, it flips upside down. If it's got a number bigger than 1, what happens? It's a vertical stretch. Good. If it's less than 1 or in between 0 and 1, vertical compression. Good. Then you've got the things happening inside the parentheses. So if there's a negative, let's say, on the front of the x inside the parentheses, what's that causing? Reflection over the y. Good. And then the number next to it is your horizontal shift, right? If there's no negative, so like it is now, it goes the opposite direction. So minus goes right, a plus goes left. But if there's a negative on the front, remember it reverses that order. So if there's a negative on the x, then it switches the horizontal translation, okay? And if there's a number there, it causes a horizontal stretch or compression. If it's bigger than 1, it's a horizontal compression. If it's in between 0 and 1, it's a vertical stretch. And then the very last thing on the outside is your shift up or down, right? Positive up, negative down. All right, 7 said identify the domain, range, and asymptote, and then the end behavior and graph the function. So I know based on the transformations that this negative means it flips upside down or over the x. So my normal log that has that R shape up and to the right flips upside down to go like that. The 3 would make it stretch vertically. I won't mark it wrong if you don't give me the factor, but if you give me the factor and it's the wrong factor, I will mark you wrong. So be careful there. It should be by a factor of 3. Then the minus 2 inside is to the right 2, and the plus 1 at the end is up 1. The vertical asymptote comes from the parentheses. So my vertical asymptote is at x equals 2. You need to plot your vertical asymptote so you can guide the rest of it. It would have been up 1, right 2, which makes sense. And then it would be upside down. It would be vertically stretched. So it doesn't have to be perfect, but something like that. This makes my domain go from 2 to positive infinity. My range for every log is all real numbers. The asymptote we already had. And then we want to do end behavior. So I need the limit as x approaches the vertical asymptote, which is at 2, and it's coming from the right. So this should be plus. And I'm going to do the limit as x approaches positive infinity. So the f of x here is going towards positive infinity, and the f of x here is going towards negative infinity.
So we don't need to plot points for the graph?
No, you can do your approximation. Yeah, if you want to plot to make sure you're right, you can, but you don't need to. Okay, then this one ends with the combination of those last two things. There is some sort of a expansion that will happen, and then you're gonna, that's a 125. It looks almost like a slash, but it's a 125. And then you're gonna talk about what that results in as far as transformation goes. If you want to graph this one, you can, but you don't have to if you understand the shifts without it, okay? I'm gonna let you work. I'm gonna kind of be watching while you're working and give you some feedback. If you've got questions, please ask. And then for homework tonight, you're gonna do the quiz review. There's a little bit more on the quiz review than there is on this class kick. This is not everything, okay? But it is a good overall of it. And the last one said identify the domain, the range, and the asymptote and describe the transformations. Your goal here is to expand this out. When I expand log base 5 of 125 plus log base 5 of x, log base 5 of 125 becomes what? 3. Now I have a vertical shift up. So you can say vertical translation up. You could say vertical shift up, but it should be vertical shift up 3. You can write up 3. That's fine. Yeah. You just can't write vertical 3. Like, you have to be more specific than that because it could be a vertical dilation or compression. So it has to be more specific than that. And then if it's just up 3, that means my vertical asymptote is at x equals 0. My domain is 0 to positive infinity. My range is negative infinity to positive infinity. It would go up like that, somewhat to the right 3.
So you can't just say horizontal compression.
Right, the goal there is to expand it. And I think maybe the wording on the quiz, I'll look at it again, but I think it says expand and then describe the translations because they are the same. A horizontal compression by a factor of 1 over 125 is actually the same visual effect as a vertical shift up 3. They do the same thing. But the goal there is to expand. So I think it says expand and then describe the transformations. Yeah. Questions for me? All right, so again, homework is your quiz review. I will repost those solutions with the corrected. I think it's 3 and 4 on the second page that need to be corrected. I'll do that now. And then tomorrow, quiz.